Welcome to my channel. In the last video, I have been covered the stack basic data structure and I also have covered the stack ADT operations. If you haven't watched, please watch that and then come back to this video. And in this video, I'll be covering how to implement a stack using array. So regarding implementation of stack, we can implement by using array and also we can implement the stack by using linked list. In concern with array, the main difference of a linked list here is like we have to know the capacity of the stack in advance. That means that we have to predefine the stack capacity because array is a static memory. So we have to know that memory in advance. But regarding the linked list, it is a dynamic memory, so it is not necessary to have that capacity of the stack in advance. That means we don't need to predefine the capacity of the stack. Only that is the main difference of a stack using array and stack using linked list. So in this video, I'll be working with a program, a C program, how to implement a stack using array. Okay, that is a task over here. So what I'm going to do is I have been open an online compiler and I have started with header file followed by defining a macro, so to define the size or capacity of a stack, because we are going to implement a stack using array. In that sense, we have to predefine the stack capacity. So why I am just using macro over here, because when I want to change the size of the capacity of the stack, I can change over only one place, which means here. I can change only here. If I want to change into 300, only 300 I can change it over here. And wherever I use size throughout my program, the 300, the 3 will be replaced by 300, which means that instead of changing the value throughout the program, okay, to find the value throughout the program and changing it, which makes you more complicated. Okay, sometimes you might have missed it also. So in that, if you're using a macro, it is easy to go with modifying the size or scaling up the capacity of the stack. So this is how you have to define a macro. You should not use semicolon, okay, hash define, and you have to give the size and I'm going to declare a size of the stack which occupies 3 elements into the stack. So now I'll start with declaring a stack. So declaring a stack is like simply like give int and then stack. It's like array, right? So I'm just using array. The capacity of that is size. So instead of giving 3, I'm giving size, because here whenever I want to change, I can change it over here. Then wherever size I have used, I'll be changing that value with that new value. Okay, so this is how you declare a stack. This is the syntax for declaring a stack, a capacity of stack or creating a stack. Okay, after that, so we know that a stack always works with only one end, which is top end. So in that case, I need a variable called top. I'll just declare that also. And initially, I'm making my stack to be empty. So in that sense, you know that always your array starts with 0. Okay, to indicate the stack is empty, I'm just having an invalid number -1, because we have to get below 0, which means I'm just going beyond the 0. So below the 0, which means -1, which is the invalid number for the array. So this top is equal to -1 indicates that your stack is empty. So this is completely, this particular line is completely creating or declaring a empty stack. So this alone declares a size of the stack and this indicates your stack is empty. Okay. Now I'll be like, once I have just given a size, we have been declare a stack. Next we'll be discussing about the function declaration, like what are the functions we need. Okay, I'll just go with defining the function prototype. So I'll be having a function called isFull, because I need to check whenever I'm working with the push operation, which means I'm going to insert an element in the stack. So when your capacity is reached, the stack capacity is reached, I could not able to insert an element. So in that case, my stack should not be full. Okay, so in that I'm just having one method, just nothing but isFull method, which takes up the top values. Next is your stack is Next is your isEmpty method. So now when I'm just deleting the element, which is popping up the element, so from the empty stack it is not possible, right? For that I'm going to check whether my stack is empty whenever I do a pop operations. So for that I'll be working with empty method. Okay, so now I have checked with is full and I have just used is empty. Now we'll go with the main functions where we are working with push, and then we'll work with the pop, and finally traversing a stack, which is nothing but displaying the stack. Okay, and one more ADT operation which we missed it, which is nothing but peek. Peek is nothing but to get the top element without deleting it. Yes, so peek, so where which I have to pass the top as a parameter. So these are the function prototypes. So you can see here we are using these many methods. So it is going to check whether whenever you just insert an element, I check is full, and whenever I do pop, I'll check is empty, and I'll be like inserting an element we use push, deleting element we use pop, to display all the element in the stack we use this method, to get the top element of the stack we use peek. Okay, so these are the function prototypes. So now we are entering into a main function. So main function is like I'm just having that a method called a push method. Okay, so I just call this for 3 times, so because I can enter 3 elements into the stack, and I'll just call one pop method, and then I'll just call a display method. Okay, and I'll just return a 0 because my main function is a type of int, so it has to return something, so we have given return 0. So now the function prototype is completed and the main function is completed. Now we'll start with a method definitions. Starting we'll be going with the is full method. So is full method, we'll just define that. So we have is full of, and it takes the parameter top. So in this case we'll be working with a condition is full. So you can see here when you are working with a stack, so in this case you can see here I have a stack. Okay, I have 3 elements in the stack, so 0, 1 and 2. So when all the elements are filled like 1 and 2 and 3, so where which I have inserted all the elements in the stack, again I am just calling a push and I am just trying to load the element into the stack, which is not at all possible because the capacity of the stack is reached. So this capacity of the stack is reached, I should get a message stating that your stack is overflow. Okay, to indicate that I should have some condition, right? So you can just see this condition when my index is starting with 0 and 1 and 2, which means that it is this 2 is nothing but my top is here now. Okay, so when my top value is size minus 1, my size is 3 here. Okay, because we have declared it as 3. So 3, but now my top value is 2. When my top is reaching the value size minus 1, then I say that the stack is full, we cannot load the elements. We have to stop inserting an element into the stack. So now you can just see here, if top equal to size minus 1, size minus 1, then I'll do what? I'll just return, because it is an int, so I have to return something. So return 1. So which means that I'm returning 1 when my stack is full. Okay, else what I'll do, I'll just return 0. Okay, so return 0 is nothing but, so we'll be having return 1 for full and return 0 for not full. Okay, so same thing you can write for isEmpty. So copy this method and you can just write it for isEmpty. So isEmpty, you just again take up the top parameter, and here, which means that you will be having a paint here. Okay, so you can see here I will be having just assume that my top value is like I have deleted this element, so I'm decrementing my top over to this position. Okay, once I delete this element and I delete this element, okay, after that, in decrementing your top becomes what? Your top becomes -1, which means that your stack is empty. So, deleting the element from the empty stack is not possible. So, in that case, we have to throw a message stating that your stack is empty. Okay, so in this case, what we have to check? If top equal to -1, then I have to return 1, else it is written 0. For full, we have to say, check with size -1, and for empty, we have to check with -1. Now, we will write with push method. Okay, so we will write void push. In this, what we have to do is, we have to just have the data here. I'll just declare a local variable called data, and then I'll be checking for the condition. So if is full. Okay, so here I'm taking a condition if, which means that if of any non-zero makes your condition true. Okay, so if of is full. Okay, if it is full, I have been writing a method. Okay, I'm just writing a message stating that your stack is overflow. Okay, and then I'll be like else. Okay, if your value is if of 0, which means that your stack is not full, I make the condition false and just entering into the else part. Else part, what I have to do? I have to take up the value from the user. So enter the data what you want to insert into, to be inserted into stack. Okay, so here after doing this, what I have to do? I have to get us read the value and I have to load it into the local variable called data. So just load it into the address of data. So that's it, completed. Okay, so your scan and the thing is completed. Once the data is loaded, now you can see here what happens. So now you can just have it here. So here we will be having a stack. Okay, think that my stack have 3 elements capacity and my top is -1. So when I need to load a data in an empty stack, okay, I have to bring my top to 0 and then only can load the data. Okay, so without bringing your top to 0, I could not insert an element into the stack. So the order is very important. You have to increment the top, do an increment of the top. Okay, so bring the top to 0. Okay, so now after incrementing your top, that is -1 plus 1 becomes 0. So top value changed to 0. After that, I am loading my data to this position 0. So stack of top. So stack of top, which means that stack of 0. Now the value of top is 0 and I am just giving the data. Whatever the data has been entered by the user, that will go into the position 0 of stack. So now what we have to do? We have to increment the top. So in this week I am just doing a pre-incrementing of top and I am just loading that into data. Okay, so now this pre-increment first increments the top value and then this complete instruction will be executed. Okay, so top value, new updated value of top will be loaded here and stack of 0 will be taken as data. Okay, so now this is completed. After this you can call the display method also, because after inserting a value you can call the display method so that you can see that whether your data has been inserted into the stack or not. So for push we have been called for if is full. When this method is called, it directly go to the definition of is full. So is full, what we did, we have checked whether your top equal to size -1. So initially your top is -1. So in this case my top equal to size -1, it is false because the top value is -1. So it goes to else. So else is nothing but return 0. It returns 0 for this method call. Okay, so what happens? You directly go and just replace with if of 0. If of 0 means that it makes this condition false. So false means it goes to the else. Okay, so in the else what happened? Asking for the a user to enter the data what they have to enter into the stack. Okay, after getting the data, we are reading the data and loading into a variable called data. Okay, after getting the data, what we are going to do, we are going to increment the top. So bring the top to the position where you want to insert the data. So after bringing up this, okay, we will be like loading that data to the top value. Okay, so after inserting, we are just verifying that whether my data has been inserted into stack or not. Okay, so same thing, now we'll be working with pop. So for pop, what we have to check, we have to check with isEmpty. Okay, so here we'll be having a temporary like I'll be having one more local variable to store the deleted element. Okay, here I'll be asking for to test with isEmpty, and this is like I'll be saying that your stack is empty, so I'll use underflow term. Okay, so my stack is underflow when my isEmpty is satisfied. Now if it is not satisfied, I'll do what? I'll just take that element which I'm going to delete it, and I'm going to load that into the variable called item. So current stack top. Okay, so I'm just loading that data into item, and then I'll just decrementing top. Okay, I'm bringing the top towards the downwards. Okay, so next I'm just displaying that element whatever I'm deleting. The deleted element is okay, the format specifier. So I'll just take that and comma, it is item. So item is loading your or taking up your deleted element. After that I'm displaying it to get back the remaining elements of the stack after deleting what are the existing elements into the stack. So top minus minus means like once I have just loaded complete the capacity of the stack, now my top will be here. Okay, so to delete the element, what I have to do, I have to delete this element, then I have to bring my top towards the below position, which means I have to decrement 1. So from 2 to 1 I have to bring, so which means I have to decrement the top by 1. That's what I'm doing here. So top minus minus. Okay, so that's it regarding the pop. So here I'm just displaying the this thing stack value after deleting it. Okay, so next we'll go with peak. Okay, so on, oh yeah, display is there, so we'll be displaying that also now. I'll take up the same method and I'll just paste it, and I'll replace with this with the display. So display, what we have to do, you can just have this, I'm just from here. Okay, I want to traverse the stack from the top always. Okay, so from the top only my elements will be there. We have to traverse the stack and we want to display all the elements. So in this case, for this I'll be like having one more local variable which is for iteration purpose. So I'll just take that, and then I'll be having if top equal greater than equal to 0. Okay, so then I have to make sure that my top, this display will work only when my top is greater than equal to 0. Okay, it will not work when your stack is empty, right? So in this case I'll be like giving a condition. So if my top greater than equal to 0, okay, then I'll just have my conditions printf. So I'll just print the elements in the stack or. Okay, the elements in the stack or. So in this case, what I'm going to do, I'm going to write a loop. Okay, I'm going to write a loop stating that for I equal to, where I'm going to start. So my iteration is going to start from top. From here only I'm just coming down, right? So I just start with top, I equal to top, and a condition is like I greater than equal to 0. So because my I value should be greater than equal to 0, and when you're starting with top, I have to decrement to the lowest position. So I minus minus. Okay, after in getting your loop, what I have to do, I am just going to take up the element and printing it, that's it. Just print the element. So stack array I. Okay, so whenever stack array starting I value is top, so whatever the value inside this position, that will be displayed. Slowly your I is getting decremented, means that your top will be reduced here. Okay, so that your value of this, whatever this is there, and that will be displayed. Slowly it will be like reaching up to the stack empty. Okay, so stack empty means like when your top be getting into the -1, then this condition will not work. Okay, so here what I can do, when my top value is going below of, okay, going below of your 0, which means a -1, when it is reaching -1, then I can just say the user the stack is empty. Okay, stack is empty, that's it. Okay, so this is done. So display method is also over. Next, last method is peek. So for peek, what we have to do, we are going to just get the top element in the stack. So void peek of in top, because I need this top element to be carried over to the method. So here if, again, if this here also my top should be greater than equal to 0, because in the empty stack I could not get the top value. If my top is greater than equal to 0, I am just printing up the top element in the stack. So here stack is, I can just get it into comma stack of top, that's it. Okay, so else I can just say that your stack is empty in case of your top is -1, that's it. Okay, so we have defined all the methods. So you can see from starting we have totally 6 methods. So where we are checking whether E is full, E is empty, then all the other ADT operation, push, pop, display and peek. And in the main function we are calling the push method. Each time whenever you call this push, it is just going to the definition of the push method, and in the push again we are calling is full method. It is going to the definition of the is full method here, checking for the capacity is reached or not. Okay, based upon that return statement this method will work. Okay, so here simply we like for push we'll just increment the top, for pop we'll decrement the top, that's it. Okay, so we'll try to execute the program. Okay, let's click on the run button and see like what, yeah, we got the output. So here we are asking for enter the data which you want to insert into the stack. Now it is started with main function always. Okay, so in the main function is like we'll be calling a push method. So in the push method is going to the definition of push, and just testing for is full. So when your top value is equal to -1 initially, the is full will not be true. Okay, just going to the else part. So now this is executing. Okay, enter the data that you want to be inserted. So okay, now I'll just give some element value here. So now what happened? So in the main function we are calling a push method. So for this push method we are coming to the definition of the push. So in the push we will be having that is full condition. So as initially you have declared the top to -1, so now my is full method throws you a false thing. Okay, my condition becomes false because my top is not equal to size -1. So it is -1, right? So it is going to else part. So else part la what we got, enter the data to be inserted. So that line we got it, and we have given 10 as a value which I want to insert into the stack. Okay, so now I am just giving 10, I am just enter here. You can see elements are in the stack. So here I am just calling the display method, that's why I am getting this. Okay, so whatever the elements I have inserted only 10. So the elements in the stack are 10. Okay, now for the second call of push. So you can see this main function. So now I am just calling here. Always your main function starts first and also like where the termination is also on the main function only. Once you call this method, after executing this function, again it is coming to the main function. Okay, so executing the second instructions of the main function, second instruction is also push, again it is going to the definition of the push. Again we got the same thing because my top is not equal to size minus 1. Now the top is the position 1. Okay, so here I am just giving the value 20. So now you can see here, so elements in the stacks are 20 and 10. Now before it was 10, now it is 20. So whatever we have entered recently, it will be the top element of the stack. Okay, so again we will be calling the third time push call, okay, in the main function. So after returning back from this call, I am just executing the push again. Okay, so in this case I am just getting that again my top is not equal to size minus 1. Again I am getting this message. Okay, now I have inserted 30. So you can see 30, 20, 10 are the 3 elements in the stack. So we have reached the capacity of the stack. Now I'm just again after returning to this call, I'm just executing a pop call here. Okay, once I'm executing this, what happens? It just delete the element, okay, from the top of the stack. So there is lost in first out, which has been lost in nothing but 30. Okay, which is recently added as 30. That will be the element which goes out. Okay, 30 is the deleting element. Okay, once you call the pop method, 30 will be deleted. After that again I am calling display method. So after deleting 30, before deleting 30 it was 30, 20, 10. After deleting 30, my elements in the stacks are 10 and 20. And 20 will be on the top of the stack. So I'll just summarize the session. What we did, we have just defined the capacity of the stack. We have declared the empty stack by indicating top is equal to minus 1, and we have been just used and declared 6 methods. Is full method to check the capacity of the stack is reached. Is empty method whether your stack is empty, and void push to insert an element, void pop to delete an element, void display to traverse a stack and to display all the elements, and peek, which is nothing but you are getting the top element without deleting it. So in the main function we are calling the method. Whenever we call push, it is directly going to the definition of push. So here we will be executing what we want. Simply we can say that for push operation we will increment the top, for pop we will decrement the top. Okay, I hope you understood the concept how to implement a stack using array in C. Okay, thank you for listening. Happy learning.